The Singapore Airlines flight from London, which experienced extreme turbulence last May, made headlines across the globe. The death of one passenger and the injury of 31 others raised serious concerns over flight safety.
The turbulence is the cause of approximately the majority of the weather-related accidents in the aviation.
While the incident may be rare, in its wake, scientists emphasize the link between climate change and the increased frequency of turbulence for future air travel.
During the last 4 decades, between 1980 until now, so we analyzed the atmospheric data and we looked at how the turbulence changed during the last 4 decades, and we found that the frequency, the probability of the turbulent events increased between the last 4 decades in many regions in the Northern Hemisphere.
The reason why we think climate change affects this is for two reasons, essentially. Firstly, in a warmer world, the ocean temperatures are warmer, there's more water vapor in the atmosphere, there's more energy available for storms, which can cause these waves that cause clearer turbulence. And secondly, this is more at higher latitudes over the storm tracks in the Pacific Ocean, the Atlantic Ocean. At higher levels, there's, for lots of physical reasons, we think the jet stream's actually increasing in strength at about 10,000 meters up for various reasons. And we think that increase in strength would be associated with an increase in clear air turbulence.
What we find is that for each degree of warming, the probability to encounter turbulence events at flight altitude increases.
Turbulence comes in three forms: convectively induced turbulence, mountain wave turbulence, and clean air turbulence. Most of the research which has investigated the impact of climate change on turbulence has focused on clean air turbulence, since it is the most relevant for aviation. However, it has been suggested that the other two types of turbulence could experience a similar increase with climate change. Aviation experts and climate scientists concluded that all three types of turbulence are projected to increase on a global scale across all seasons as a direct consequence of climate change. This graph shows the difference in encountering moderate or greater clean air turbulence in the years 1979 and 2020. You can see an increase in probability specifically in the east coast of America. Other research has projected significant increments in clean air turbulence by 2050, extending through a period of 3 decades. The most notable of these increases will be along the mid-latitudes, which are already the site of the busiest flight routes in the world. So how exactly is global warming causing turbulence? Imagine the atmosphere as a vast ocean with waves and currents. Just as ocean waters can be smooth or choppy, the air around us can also move in unpredictable ways, in smooth, steady streams or convoluted swirls. When a plane flies through an area where the air is swirling in different directions or currents are colliding, we experience turbulence. Jet streams are the fastest flowing currents of air in the sky. We can think of them as superhighways. When the plane flies from an area of slow-moving air into the jet stream, it encounters turbulence known as wind shear. When the boundaries of jet streams flicker or change rapidly, this can also cause turbulence even in clear weather. This is known as clear air turbulence. This instability in jet stream boundaries tends to rise as climate change deepens. Simply explained, the disruptions in global temperatures resulting from anthropogenic forcing or human involvement are impacting the way in which temperature gradients operate. This means that the emission of gases which trap heat, such as carbon dioxide, are increasing the frequency of turbulence.
And in this region, in Asia, North Africa, so we have what we call it the subtropical jet, which is so strong winds at approximately between 10 and 12 kilometers up. And in this jet stream, so we have strong vertical wind shear, changes in the wind speed in the vertical, in all these regions.
The jet stream is made up of masses of cold air which descend from colder regions like the Arctic and warmer air from regions like the tropics. The stream consists of steep troughs and ridges since the denser cold air sinks downwards while pushing the lighter hot air upwards. This gives the jet streams their wavy appearance. This is a pattern which is followed across Northern America, Asia, and Europe as masses of cold air migrate from the Arctic, creating waves of differing patterns. These disruptions to the jet stream lead to increased flight times and complications in the planning of routes. since strategies must be implemented to avoid turbulence. This leads to positive feedback, where the human factors which were responsible for the disruption in the temperature gradient and the jet stream now lead to even more carbon dioxide emissions and even higher temperatures. So, what is the future of research in climate change and the stakeholders in aviation?
Now, basically, our research, we showed that global warming will increase the turbulence. So now we have to, as you said, we have to look at the solutions to mitigate this.
The alarming increase in turbulence has led to concerted efforts to reduce the risk it poses for aviation. The European Aviation Safety Authority (EASA) emphasizes increased cooperation between EU nations under a new strategy of forging a climate-resistant Europe. Under this initiative, member countries are encouraged to work together to implement and strategize solutions which reduce the risk of climate change, and this extends to turbulence. Rougher skies are a concern for birds as well. Researchers at Swansea University are using animal behavior to help understand how birds are adapting to turbulent skies. While it is rare for birds to encounter the same levels of altitude as aircrafts, their responses to turbulence at lower altitudes can help scientists make better models for predicting turbulence. The way different species of birds adapt to this turbulence can also be used to conceptualize models for future aircrafts which travel through more turbulent skies. This is especially useful in environments where smaller aircrafts are more common. Scientists are even using birds as airborne detectors for heavy turbulence in the same way that seals are used to detect the temperature of the sea and its level of salinity.
And lots of work has been done in fields of meteorology, aviation meteorology, to come up with metrics and measures to try and forecast clear air turbulence.
It is anticipated that research by these scientists will be incorporated by the aviation industry as climate change increasingly becomes a critical focal point of national and global policy. Aviation experts must work to mitigate risks associated with turbulence if they wish to ensure safe flights across the busiest flight routes in the world.